When we think about the sun, we usually think about its constant energy that enable life as we know it to thrive on planet Earth. This solar warmth and energy drive a multitude of biological and chemical processes, not only on our planet, but also throughout the entire solar system. Our reliance on the sun extends beyond sustaining life as we know it. The sun plays a pivotal role in Earth's climate and weather patterns, powering the water cycle, wind patterns, and ocean currents that shape our planet's climate zones. Solar energy is harnessed for a wide range of purposes, from providing electricity through solar panels to driving photosynthesis in plants, which forms the basis of our food chain. However, in addition to its advantages, the sun releases solar flares, coronal mass ejections, and various forms of space weather, which could potentially have disastrous effects on our civilization. Let's delve into what everyone should understand about the sun's potential threats. When considering the dangers the universe may pose to Earth, our minds often gravitate toward the more conspicuous catastrophes that have occurred throughout our planet's history. Events such as asteroid and comet impacts have inflicted devastation and triggered mass extinctions, and there is a clear likelihood of future impacts. Furthermore, nearby stellar cataclysms, such as supernova, or the lurking threat of wandering black holes adds another layer of existential danger, capable of consuming our world without the slightest warning. But we often ignore what is visible and obvious. The sun could harbor an unexpected threat for us, a solar storm or coronal mass ejection, to be precise. While on a daily basis, we have more immediate concerns, it's crucial to recognize that in the years and decades to come, a direct impact from a catastrophic space weather event is virtually unavoidable. Solar flares, the explosive outbursts from the sun's violent core, are one of the universe's most magnificent spectacles. These eruptions are born from the sun's intricate magnetic dance. As magnetic fields become twisted and tangled, they release energy in a spectacular display that can rival the combined power of millions of atomic bombs. What sets giant solar flares apart is their sheer magnitude. Within minutes, they can emit more energy than all of humanity has consumed throughout history. Now the question arises, how do these colossal eruptions affect our world? The answer lies in the complex relationship between the sun's fury and Earth's magnetic shield. When a giant solar flare occurs, it hurls a barrage of charged particles towards our planet in what we call a solar storm. These solar storms can set off a celestial light show, northern lights or southern lights, depending on which hemisphere they appear. When these charged particles interact with Earth's magnetic field, they create dazzling, multicolored displays of light in polar regions. It's a breathtaking spectacle, one that has inspired countless stories and myths throughout history. However, beneath this celestial beauty lies a sinister potential for chaos. The charged particles from solar flares have the capacity to disrupt vital infrastructure on Earth. These disruptions can devastate radio communications, navigation systems, and power grids, casting society into disarray. The first recorded solar flare, the Carrington event of 1859, serves as a stark reminder of the sun's disruptive potential. Solar astronomer Richard Carrington, during his observation of a large sunspot, was witness to an unprecedented white light flare of staggering brightness. Little did he know that this flare would trigger the largest geomagnetic storm in recorded history on Earth, causing telegraph systems to malfunction. Skies all over planet Earth ignited with a breathtaking display of red, green, and purple auroras, their brilliance rivaling the light of day itself. The northern lights were witnessed as far south as Cuba and Hawaii, whilst the southern lights were seen as far north as Santiago, in Chile. Carrington made the connection and realized that the solar flare he had observed was very likely responsible for this extensive geomagnetic disruption. Furthermore, the Carrington event wasn't a one-time occurrence. On June 23, 2012, a solar flare of equivalent energy to the Carrington event was released by the sun. Fortunately, the sun's rotation spared us from a direct impact. If the flare had occurred just 9 days earlier, Earth would have been in its path. Today, with our intricate global electrical grids and widespread use of electricity, a similar event would result in a multi-trillion-dollar disaster. Solar flares may not pose an immediate threat to humans, but they have the potential to generate colossal electrical currents that surge through our interconnected infrastructure. To transform into a catastrophe, 3 critical conditions must align. Firstly, a massive solar flare must originate from the sun's corona rather than its photosphere. Secondly, Earth must possess an extensive network of electrical infrastructure, including large area loops and coils of wire. This condition we already fulfilled. And thirdly, the flare's eruption trajectory must be precisely anti-aligned with Earth's magnetic field. This alignment could lead to the rapid arrival of charged particles, overwhelming Earth's magnetosphere and causing potent auroras to envelop the globe. These particles could induce severe currents in power grids, resulting in power surges, electrical shorts, fires, explosions, and crippling blackouts. The loss of communication infrastructure would hinder emergency response efforts, and essential services like heating, cooling, and the delivery of food and clean water could be disrupted, endangering lives. To mitigate this threat, investing in early detection systems becomes imperative. Given that we now have sun monitoring satellites and observatories, they are our first line of defense to alert us when a space weather event is potentially threatening the Earth. In August 2018, the Parker Solar Probe embarked on its historic journey, becoming the first spacecraft to touch the Sun. NASA's cutting-edge spacecraft mission is to investigate solar wind, magnetic fields, and the origins of solar storms. Although significant strides have been made in this regard, preparations must extend beyond detection. Our power grids, energy distribution systems, and global population need to be ready for the inevitable. Until we secure our infrastructure and prepare for the worst-case scenario, the price we may ultimately pay for repairs will far exceed the cost of adequate prevention. The silent threat from our sun persists, serving as a stark reminder of the ever-present challenges posed by the universe. Join us on our cosmic journey as we delve into the mysteries of the universe. To stay updated with more extraordinary tales from space, subscribe to our channel. And if you found this exploration as awe-inspiring as we did, don't forget to hit the like button.